Basic linear regression analysis consists of one dependent variable and one independent variables. With assumptions error terms are normally distributed, mean zero and constant variance. The equation for linear regression model can be written as follows. So we have y, the dependent variable, and then x, the independent variable. So how to determine which one is the dependent, which one is the independent variable? The independent variable is the variable that can be manipulated. For example, weight, for example, and how much we consume, how much we eat. Okay, so the weight is depend on how much we eat. Okay, how much calorie that we consume. Okay, so we can manipulate how much we want to consume. Okay, but we cannot manipulate the weight. So y will be the weight, and then x will be the amount of calorie that you consume. Based on the simple linear regression model, we need to estimate the beta 1 and the beta null. Beta 1 is the slope, and then beta null is the intercept. So this is the formula to estimate the beta 1, and this is the formula to estimate the beta null. Okay, so I will proceed with the built-in function on how to run the simple linear model. Okay, let's say I use the same data set, the iris data. Okay, run the regression model using the ln function. Let the sepal length to be the dependent variable and petal length as independent variable. Okay, so we want to build a linear regression model based on these two variables. Okay, so I just copy this one, right click, copy, then paste on here. Okay, LM is a linear model, a simple linear regression model, and then run. Okay, if you click iris model, run the iris model, so you will get the estimated beta null and beta 1. Okay, so therefore when you write the equation, okay, you will write as y hat equal to 4.3066 plus 0.4089 x1. Okay, and then e is assumed equal to 0. Okay, and then to get the detail of the analysis, we use the function of summary. Okay, so if you type summary of iris model, okay, you will get the analysis of the residuals, the coefficient. The coefficient is the p-value here, is very important. We want to say whether the petal length is significant or not. In this case, the p-value less than 0.05, so petal length is significant and can be used to predict the sepal length. And then the F statistic 468.6 is sufficiently large to say that the model is significant with the p-value very small, 0.00, less than 0.05, and the R squared 0.76, so we can say that 76% of the variation in the in the sepal length can be explained by the petal length. Okay, this is how you interpret the output from the R programming here. And then you can also do the analysis of the residual based on the plot. Okay, actually if you type plot iris model, okay, enter, sorry, okay, so it will return to you the residual plots to determine whether the error terms meet the assumptions of normality, the constant variance and independent. If you want, actually there are 4 plots for the iris model. If you want to put 4 plots in one graph, okay, you type the following code. Okay, PAR is the parameter. Okay, MF row C22 meaning that 2 row 2 column. Okay, run this one and then plot the iris model. Okay, so you will get okay, run the parameter first, okay, and then plot the iris model. Okay, so you will get the 4 plots in one interface, okay, or in one page. Okay, the next one is the multiple linear regression. Multiple linear regression model consists of more than one independent variable. So in this case, we have x more than 1. So let's say we use the same data with the dependent variable is the sepal length, and the independent variables are sepal width, petal length and petal width. Okay, so maybe I should hide here. Okay, so you can, let's say, iris multi-iris model. Okay, multiple regression model. You can type here LM represent as a linear model. Okay, you type the independent variable first, sepal dot length, and then put the tilde and then list of the independent variable, sepal dot width plus petal length plus and petal dot width. Okay, and then define data is from iris. Okay, and then run. So if I just run the multi-iris model, okay, so I will get the full equation or the full estimated model for the multiple linear regression of the sepal length. So you can see that y hat is equal to 1.8560 plus 0.6508x1 plus 0.7091x2 minus 0.5565x3. So we have 3 independent variable included to the model. Okay, and then if we want to get the complete analysis or detailed analysis of the multiple linear regression, okay, you can just type summary of the multi-iris model. Okay, so you will get the descriptive on the residuals, the result of the coefficient. Okay, so the result of the coefficient, you refer to the probability value. If the probability value less than 0.05, so we can say that the independent variable is significant. And then the F statistic 295.5 is sufficiently large to say that the model is significant. P value is also very small, 0.000, less than 0.05, and then the multiple R squared 0.8586, so we can see that 85.86% of the variation in sepal width, petal length, and petal width 85.86% variation in sepal length can be explained by sepal width, petal length, and petal width.